Hello everyone. So, in this series where we are talking about perception, cognition and sensorial modalities, it is time for us to now discuss about the sensorial modalities. So, we will be talking about multimodal interaction and sensorial design. So, the learning outcomes of this particular lecture are we will see how to combine the visual, auditory, haptic, and kinesthetic modalities to design richer, more accessible experiences. So, we will design feedback that matches its function, like acknowledgement, how to show progress, how to show when an error has happened, and how to depict completion, and lands inside the right perceptual timing window. We will apply gesture, voice, and multimodal redundancy patterns, then validate them with the right user research methods. So, what is multimodal interaction? Multimodal interfaces combine multiple inputs and output channels. So, your input can be touch, the tactile, voice, the auditory, gesture, the kinesthetic, gaze, visual, and the output can also happen through multimodal channels. So the visual, which is through the display, auditory, the sound which is coming out of it, the haptics, you might experience some kind of vibration, some kind of force feedback. Humans naturally integrate information across all these modalities. Seeing lips move while hearing speech is something which is expected and normal. If you see that speech is going in a different pace and the mouth is moving in a different manner, then you can quickly perceive that there is something which is going wrong over there. Multimodal design is richer than single modality. So, when we are looking at these modalities, so let's look at the output modalities. So when I'm trying to give some kind of feedback, so let's say I want to give some kind of visual feedback. So I can do that by using some kind of animations. The animation can tell you that you have successfully completed the task or the task is under progress. You are getting that feedback. Some color changes can happen. So when you click onto something, then that is a different kind of a color as compared to when it was not clicked. Notifications are another kind of feedback. Highlights indicate the state change. So you might see that if something you are on a certain tab, which is the selected tab, that has a different kind of an highlight which gives you the feedback that that is the selected tab. So it is the strongest modality for most users and it is accessible to people with hearing loss, limited by attention and visual impairment. Then comes auditory feedback. So all kinds of sound, speech, beeps confirms your actions. So that's why I call them as auditory feedback. It captures your attention effectively, not usable in silent context. So say for example, library, it demands silence. So you cannot use it over there. In meeting rooms, again demands silence. So you cannot use it. Challenges for people with hearing loss and works while eyes are busy doing something else. Now coming to the haptic feedback. So different kinds of vibration, force feedback. So let's say I'm trying to pull a particular lever and as I pull it down, the force required to pull it further down increases, giving you a perception that your effort is increasing or maybe you should stop now. Texture provides the tactile sensation of using something. The phone vibration a strong signal despite noise. So even if you're not able to hear it or your phone is on silent, the vibration feedback can still keep working. The force feedback in gaming is a very good example. Limited in web app or app interfaces and requires hardware support in order to be able to provide it. Then comes multimodal redundancy. So whenever you have certain important confirmations, you should use multiple modalities. So assume that one of the modality is not accessible to people. So say for example, you are in a noisy environment, so the auditory feedback is not available to you. So in that case, the visual feedback and the haptic feedback will still be able to give this indication that a confirmation is required before you are going to delete something, say for example. So visual plus auditory, when you are trying to do a form submission, you can do visual plus haptic like a button press, and you can always also design with all the three modalities, considering accessibility for different kinds of people, and also the fact that if one of the modality fails, you still have other two modalities which can succeed. So when we are doing this output design, it is always a good idea to design for redundancy for all those contexts where the particular feedback is extremely critical. So if I missed onto that feedback, I might end up deleting something or destructing something irreversibly. Now coming to feedback by function. So feedback is not one thing. Each stage of an interaction needs a different type of feedback. So answering a distinct question in the user's mind. So say for example, I have acknowledgement. Did my input register? So let's say I am typing something. So you need to know when you are typing whether your input got registered or not. So the system has to receive the action and ideally within 100 millisecond give you an acknowledgement. Any delay than 100 milliseconds makes the user feel that their action was not successful and they will start repeating the input of the same actions. Now coming to progress. So you need to tell, is it working and how far along have you come? So continuous feedback during a sustained action. So let's say I am trying to download something, or I am trying to upload something, or I am trying to build a particular form which has multiple pages. So I need to keep seeing that yes, it is working, so progress is happening. And if I had to move to the level 100, which is like complete cycle, where am I right now in that particular cycle? Then comes completion. Did the action succeed? So a distinct and unambiguous end of task signal has to be designed. Status. What status is the system in right now? It should be persistent. So let's say I look at it. Okay, right now it is in the normal state, and it should be also glanceable. So I looked at it. Oh, it is right now in the normal state, and then I go to do something else, and I again come back to class. I still should be able to see, yes, it is still in the normal state. So the status should be persistent as well as glanceable. So what it implies is, let's say I have some kind of error messages also coming here. So it should not be like I have to read through the error messages to understand that an error has happened, but it is glanceable because a red bulb is glowing over there. Now coming to error warning. Something is wrong. So attention capturing and interrupts if safety critical. So in case an error has happened and it is safety critical, then I should be able to capture the attention. So let's say task is going to irreversibly break or some kind of damage is going to happen. So along with that red bulb, I can make, rather than the red constant glowing, I can make it glow and stop, glow and stop. That's a kind of a feeling that there is some kind of urgency. I can combine that with a high pitch alarm sound, which again alerts to people that there is something which is alarming and you need to take action right away. So for minor errors or warning, it might be enough to put red light glowing over there. So if I come back and I see that my dishwasher is glowing red, I know that I have to do some intervention, some error has happened. However, if it is machine which is on the assembly line and your next product is blocked because of certain activity, and as a result the entire assembly line has stopped, you need to have a big warning sign which tells people that quickly come and pay your attention over here. Then the sixth one, which is about confirmation. So about to do something irreversible. So let's say I'm going to delete something. So there I need to have a deliberate pause. So I press the delete button and then you have this question. Are you sure you want to delete it? Or are you sure you want to proceed with it? And then there is this deliberate pause. So I read it and I decide yes or cancel. So whenever there is a possibility of irreversible action, give a deliberate pause for people to think about it and then take appropriate action. Feedback timing. So there is a relationship between how soon the feedback is provided to the user and what impact does it have on the perception of that feedback. So we call that as the perceptual window. So when feedback arrives, matters as much as what it says. So delay breaks the perceived causal link between an action and its responses. So say for example, when you have a feedback which comes under 50 millisecond, so these are all those feedback which are meant for action and feedback fuse. So the response feels almost instantaneous. So I am typing on the screen or on a keyboard, and it gets the letters become visible on the screen. Plus, as I am typing, I also get a haptic feedback or a sound feedback. So the action and the feedback are almost fused because the gap between the two is less than 50 milliseconds. So the response feels instantaneous. Mechanical detents, snap fades and haptic stops live in this particular window, and we use them to give this feedback. Now, if your feedback happens in this time range of 50 to 200 milliseconds, then they are recognized as immediate response to the action. The window for LED changes, audible clicks, and confirmation beeps are this particular window. Now, coming to 200 millisecond to 1 second. It is a noticeable delay for human beings. So let's say a progress indicator which shows that how much of the download has happened or how much of the form has been filled. So the progress indicators can use this kind of a delay. So show a progress indicator so the users know the system is still working and continues to wait. So whenever you think that there is that much time frame required to make the task happen, we always build in this progress bar so that people know that yes, the task is keeping on happening. So it happens every time you are downloading something, copying something, uploading something, or let's say you are filling up a form which takes a lot of time to do it, and that which means the feedback time, the feedback of completion, that is very delayed over here. So in that case, I put a progress bar so that my feedback again falls under these two particular categories, and I would not start thinking that something is going wrong. Then comes beyond 1 second, perceived as a separate event. So requires explicit progress feedback and reassurance to prevent repeated or forced input. So if you are expecting, because of whatever the system requires to do in the backend or whatever the limitations of technology are, so if you think that the actual feedback will come 1 second later, you have to explicitly tell people that we require about 5 minutes to complete this task, and we will let you know when this task is completed. So giving them the reassurance to prevent this repeated or forced input, or the fact that they just completely abandon the task. Now coming to input modalities. So how users control systems. I can control the system using touch gesture, voice control, gaze tracking, gesture recognition, and so on. So when to use touch and gesture. So whenever you have a requirement for direct manipulation, so touching objects on screen feels intuitive. Gestures like swipe, pinch, rotate, they enable advanced control. However, the challenge over here is you need to be really close to the interface on which you can do this touch or gesture. If your hands are wet or you are wearing gloves, again that comes in the way of this particular interface's success. Coming to voice control. So natural language interface like saying, hey Siri, set timer, or hands-free, eyes-free operations. However, this becomes challenging if it is a noisy environment or there are accents, like people speak in different ways. In India, people speak English or Hindi or any other language with influence from their own mother tongue. Also privacy concerns, because when I am speaking and I am in public, others are also able to hear me. Also, there is limitation for precise control. Coming to gaze tracking. So eye positions controls the interface. It enables control for paralyzed users. However, there are certain challenges here too also, like it can cause eye fatigue. There are calibration issues. Again, privacy concerns because the interface is constantly tracking your eyes and it is way much slower than hand control. It requires certain degree of practice from the user in order to get used to this. Coming to gesture recognition. Body movements control the interface. So it enables touchless control. However, the challenges are it requires a camera. As a result, there is a privacy concern, and there are also, so you might not be in isolation, and also the real world has cluttered interfaces. So there might be other people or there might be other objects which might interfere in the recognition of the right kind of gesture. So when you are designing for gestural interactions, you have to design it in a manner that there is discoverability. Users must learn a gesture exists without a manual. So use coach marks, onboarding animations, and visual hints. You have to ensure ergonomic comfort. So gestures must be sustainable over repeated use. Avoid the gorilla arm fatigue of mid-air interactions. Reversibility. Every gesture triggered action should be undoable so that accidental activations can be undone. Usually it is seen that in gesture triggered actions, this accidental activation is quite frequent. Consistent mapping. The same gesture must produce the same result on every screen and context within a particular product. And if there are industry standards for that, follow those standards in order to make it easy for your users to learn. Graceful degradation. Always provide fallback like buttons, tap targets, or voice. So never rely on the gesture alone. Now let's look at some of the gestures. Most of you are aware of these particular gestures, the tap gesture. So we have gotten used to it that it is used for selecting or activating something. The universal gesture and touch targets should be at least 44 pixels in size. Then the long press. It is the secondary option or context menu. It must be taught to the user. Swipe. Scroll, dismiss, or reveal actions. Direction carries a consistent meaning. Now that consistent meaning has always been created, so try to use that. If you have to have a deviation, then you will have to train your user in that. Pinch or speed. Zoom out or zoom in, that should have a natural mapping. So when we are making our fingers go far away versus when we are making it move in, what is the natural perception, which is zoom in and which one is zoom out. And it should be discoverable by novices also. Rotate. An object with a 2-finger twist. So these are rarer gestures and mostly available in maps and design tools. Beyond that, this gesture is still rare. So see if people will be able to recognize that this gesture can be performed on your particular interface or not. Double tap. Toggles zoom. Avoid as a primary trigger. It is easily done by accident. Designing voice interactions. So design it so that people know that brevity is the key. So audio cannot be skimmed. Keep prompt short and front load the most important information. So I should have a concise voice prompt which is approximately 5 seconds long. So verbose voice prompts which are like 20 seconds or much longer, they cause a lot of problems. Confirmation. Confirm critical actions before executing them. Match the confirmation to the level of risk. So I can say that Alexa delete my cart items and Alexa should confirm before executing that task. Depending on how severe the risk of that action is, design the confirmation accordingly. Error recovery. When misheard, recover gracefully. So rephrase offer options, then fall back to a manual interface. So let's say Alexa tells me, sorry, I could not place the order, or sorry, I could not understand what you said. Can you repeat the command? Or in case it is totally not possible to do the activity, then you can say kindly use a manual interface because I'm unable to do it. Persona consistency. So voice, tone and vocabulary of this particular voice interaction system should be consistent. So the agent feels like one coherent personality. There should be context awareness. Remember conversational context within a session so follow-up questions feel natural. So if I started ordering something and I'm in the process of doing that, agent should keep remembering the context so that the follow-up questions feel natural. Otherwise it will feel that this agent does not work, it forgot what we were trying to do. So conversational patterns for voice, you can use multiple kinds of patterns. So it can be a one-shot command, a complete request in a single sentence like turn off the lights. The most efficient voice interaction happens this particular phase. You can also design for slot filling dialogue. So the system asks for each missing parameter in turns. So it is suited if you are trying to do some kind of booking, some kind of order placement, or filling up a form. Disambiguation. When a request resolves to several options, the system asks a clarifying question before acting onto it. So like Alexa can tell me, in your order history, I found 5 different kinds of detergent being ordered. And these are X, Y, Z, A, B. Now tell me, which one would you like me to add to the cart right now? Progressive disclosure. A brief answer first with details offered on request. So I can ask Alexa, how is the weather now? So Alexa can first tell me that the weather right now is so and so. Would you also like to know about the weather for the next 10 days? So I have a progressive disclosure. It avoids overwhelming the listener. Now designing multimodal redundancy. So redundancy is something that you build in your design whenever it is about designing for the different scenes. So I deliver the same critical messages on 2 or more channels at once. A completed form can confirm with a visual success state, an audible chime, and a haptic buzz together. If the user misses one channel, looking away in noise, phone is in the pocket, another still carries the message. So redundancy is the core safety mechanism of a multimodal design. So complementarity, so divide the work. So let each channel do what it does best. So visual carries the precise detail and persistent state, auditory captures the attention instantly, and haptic gives private eyes-free confirmation. So routing each kind of information through its most efficient channel spreads the load and keeps any single sense from being overwhelmed. Multimodal interaction, so why it matters for user research. Let's look at it now. So experience is always multisensory. So users perceive through the sight, sound, the touch, and the movement of something. So research must capture all of them. So a driver hears the lane departure chime, feels the steering wheel vibrate, and sees the warning icon simultaneously. Now, single channel studies always miss some amount of data. So let's say I am doing a screen only recording, and what it will lose is all the video cues, the haptics, and the physical gestures that the person is doing. So usability test of a fitness app miss that users tapped the watch face because only the phone screen was recorded. So that kind of thing can happen. So think of all the channels that are important for you to capture when you're trying to do a user research. Ability and preferences vary. So one user reads the screen, another waits for the chime, and a third feels for the buzz. So research must record which channel each person actually uses, not assume a single default. Then accessibility is also about multimodality. So redundant modalities are how diverse users complete tasks. So you should also study that and do not average it away. Blind user navigates a map app via voiceover plus haptic ticks at each turn. Sighted users glance and ignore both of them. So these are the things that you need to keep watching and plan for watching it when you are trying to do a user research. So user research methods that you can use for testing each of these modalities. So observe users completing tasks while you record the audio, the screen, the hands, and posture. See which modality they actually used. So watch whether shoppers are tapping, swiping, or asking voice search to filter a particular product list. Now, Wizard of Ooze studies, where you actually do not have the actual prototype. So what I am trying to do is creating a simulation. So simulate the haptic, voice, or gesture responses behind the screen to validate feedback design before engineering it into a prototype. So a researcher manually triggers the buzz when a smart watch alert is missed. Comparative modality trials. So run the same task with different feedback configurations. So on haptic only versus haptic plus visual configuration, and measure is there a difference between the error rate, the speed, and noticing the what went wrong or whether the action happened or not. So isolates which modality combination actually performs best to make a decision whether it should be there or it should not be there. Then coming to biometric and behavioral measures. So you can use eye tracking, galvanic skin response, GSR, and reaction time alongside think aloud to triangulate cognitive load across all the modalities. So let's say you see that the pupil dilation spikes when the audio plus visual alerts fire at the same time. So it tells you that there is a spike in the cognitive load. And then from the think aloud protocol, the person might also say something, verbalize something, what is going on in their mind, what is the decision process, or whether it feels too overwhelming. So that will help you in making a decision what kind of improvements you can do in your design. So the key takeaways from this particular lecture are: design for all the senses. So combine visual, auditory, haptic, and kinesthetic channels. Meaning is built across modalities, not in any one alone. Reduce the load with redundancy. So when I'm saying reduce the load on one of the perception channels. So whether it be visual, auditory, tactile. So provide the same critical information in more than one modality so users can switch when context or ability demands for it. Accessibility is default. So design for users who can't see, hear, or feel a given channel. So multimodal redundancy is what makes that possible when you're designing like that. Validate with real users. Use the right research methods, whether it is a combination of usability tests, wizard of Oz, contextual inquiry, biometrics, and prove that each modality is actually working. So always remember, the sensors are not channels for information, they are tools for interaction, for building meaning in a particular context. So some more key takeaways. Each modalities have a particular role to play. So the visual, the auditory, the haptic, the kinesthetic, they carry information best suited to their strength and use it accordingly. Feedback is equal to the function and the timing gap between the two. So every signal must answer a specific question, whether it is meant for acknowledgement, progress, error, or completion, and it should arrive within the user's perceptual window. Gesture and voice have certain rules. So gesture needs discoverability, ergonomics, and reversibility. Voice needs brevity, confirmation, error recovery, and context awareness. Context picks the modality. So whether you are in a car, you are in the library, or you are on a video call, the environment dictates which channel works the best. So design redundantly so users can switch. So that brings us to the end of this particular lecture. Here are some of the references that you may go through. Thank you so much. I will see you in the last lecture of this week. Bye.